The problem is from GATE 2022 mathematics paper, question number 29. The problem given is the number of zeros of the polynomial given as 2 times z to the power of 7 minus 7z to the power of 5 plus 2z cube minus z plus 1 inside the unit disk, that is the set of all complex numbers z in C, such that mod z is less than 1 is dash. So it is asked to calculate the number of zeros of the polynomial as given this polynomial inside this unit disk. So the NPTEL reference to solve this problem is the module 1 lecture 2 of advanced complex analysis part 1. The title of this lecture is the argument principle, Roche's theorem and the fundamental theorem of algebra by Dr. T.E. Venkata Balaji, and he is from Department of Mathematics, IIT Madras. Even you can watch this reference video using this YouTube link. So now coming to the solution. So the polynomial given is 2z to the power of 7 minus 7z to the power of 5 plus 2z cube minus z plus 1, and the disk is z in C, such that mod z is less than 1. So now we solve this problem using Roche's theorem, and the statement of the Roche's theorem is for the analytic functions for the analytic functions f of z and g of z on D union dou D, that is simple contour D and on the boundary dou D with no zeros on dou D, and with the condition modulus of f of z plus modulus of g of z, modulus of f of z plus g of z is less than modulus of f of z on the boundary dou D. Then the number of zeros of f of z and f of z plus g of z is same inside D. Of course, this should be counted with multiplicities. So now by using this Roche's theorem, we solve this problem. So for this, we have to choose the two functions f of z and g of z in such a way that f of z is greater than f of z plus g of z. Sorry, there is a mistake here. And modulus of g of z is less than f of z only on that boundary dou D. Then the number of zeros of f of z and f of z plus g of z is same inside D. So now we have to choose the two functions f of z and g of z in such a manner that the condition g of z is less than f of z holds on the boundary dou D. And here we have to choose in such a way that f of z plus g of z should be this entire polynomial. So for that, what we choose is, so we choose f of z and g of z in such a manner that the condition g of z is less than f of z holds on the boundary mod z equal to 1. So I'm choosing the value of f of z as minus 7 times z to the power of 5 and g of z as the rest of the polynomial, that is 2z 2z to the power of 7 plus 2z cube minus z plus 1. So then on the circle mod z equal to 1, we have the absolute value of the function f of z is modulus of minus 7 z to the power of 5, and this is nothing but 7 times mod z to the power of 5. And since we are calculating on the boundary mod z equal to 1, so we have this as 7 times 1. And whereas coming to the absolute value of the function g of z, we have this as modulus of 2z to the power of 7 plus 2z cube minus z plus 1. So this, the upper bound for this function g of z is 2 times mod z to the power of 7 plus 2 times mod z cube plus mod minus z plus 1. And since we are calculating on the boundary mod z equal to 1, so I can just replace mod z with 1. So in total we get this as 2 plus 2 plus 1 plus 1. This has 6 in total, which is less than 7. That is nothing but the absolute value of the function f of z. So in total we have that modulus of g of z is less than modulus of f of z on the circle mod z equal to 1. So, so by the Roche's theorem, the number of zeros of f of z and the number of zeros of f of z plus g of z inside mod z equal to 1 is same or same. So for this, now we have to calculate the number of zeros of the function f of z. And whereas we have chosen the function f of z as minus 7z to the power of 5. And we can see easily that the zeros of this function f of z are nothing but the point z equal to 0. So we have, since f of z, that is, as we consider 2z to the power of 7z to the power of 5 has 5 roots. This is counted with when we take counted with multiplicity. 5 roots inside mod z equal to 1. So in total f of z plus g of z, that is in total the given polynomial, that is 2z to the power of 7 minus 7z to the power of 5 plus 2z cube minus z plus 1. This is our given polynomial, has 5 roots inside mod z equal to 1. That is what it is asked to calculate. So, the answer is 5. Of course, it is given here that mod z is less than 1. That is what we calculated. Which I said inside inside mod z equal to 1. That is nothing but mod z is less than 1. So, and of course, since it is the polynomial of degree 7 and it has the 5 roots inside this circle mod z equal to 1, and the rest of 2 roots will contain outside the circle mod z equal to, and can be on the circle also. So the rest of the 2 roots can be outside or on the circle mod z equal to 7. But here it is asked to calculate the number of zeros inside the circle mod z equal to 1, and the number of zeros are 5. Thank you.